Hello everyone, it's time for a new game development series, and this time we're going to create a clone of the classic columns game. So let's get started. So we'll create a new project. This time we're targeting iOS, and we'll start with the app template. So we'll call this the call tutorial, and we will use Swift UI, Swift, and no storage, and we will include test. We need a place to save it. Sure. So let's run it to see if we have a working environment. Okay, so that is working. Perhaps now the simulator the preview will also spring to life. Wow. Okay, cool. We can make this a bit smaller. So again, we're going to use SpriteKit. So we're going to import SpriteKit, and we will, instead of this thing, we will have a sprite view. This requires a scene. And let's give it some options. So we'll say ignore sibling order. This helps with performance. And we'll also have some debug options. We will show the draw count. We will show FPS. And we will show the node count. And we will ignore the safe areas, so we fill the entire screen. Wow. Okay. So this we have at least a sprite view now rendering. So let's start creating a bit more of a game. So I am going to create a new file called game scene, and I'll import SpriteKit, and I will put the game scene class in there. And to be able to show something, we'll override the did move to view method, and we'll set the scale mode to aspect fit. This way we always have the entire scene shown regardless of the size of our device. And we'll set the background color to black. Let's start drawing the actual gameplay screen. So we can do that by creating a field. This will be an SK shape node, and this will be a rectangular starting at 0, 0 with a width of well, we need to define how big our play field will be, and this will be dependent on sorry, both a sprite size. This will be 32 pixels, and the amount of columns. So I checked in the original columns, the width of the play field is 6 and the height is 13. So now we can use those to calculate the how large the rectangle should be. So we'll take our sprite size and multiply it by the call count cast as a double, and we'll do the same for the row count. We will make the outline white, and we will fill it with a dark gray color. Then, I think we can build and run. Oh, we should add it as a child. I think we should be able to build and run this. And this looks really weird, and that's because it's sort of really zoomed in. We can fix this by going to our content view and making sure that we define the size of our game scene. And what we need in terms of size is 375 points wide and 667 high. Let's build and run again. And now we have our playfield. However, it's anchored to the 0, 0 position, and I want it to be in the center of the screen. So we need to offset it a bit. So let's create an offset. And to do that, we will take the size we have and divide it by 2, and then take the field frame size width and also divide it by 2, and we do something similar for the height. So we take the size dot height, and this one we do a bit different because I don't want it to be centered completely. I want it to be sort of a bit higher, and after playing around, I think these are values that can work well. Oh, and we should of course use this offset to take the position, set the position to the offset. Okay, so now we have this thing sort of floating around. It doesn't overlap with the dynamic island and those important things, but we can see stuff coming in from the top. So I think this is a nice position to have it in. I'll also set the Z position to -1. This way everything I will draw will be drawn in front of it. And okay, so we have a board now. So I think what we can do is let's draw some gems in the board. So let's say we have and for y in, we create a gem, and this will be a circle of radius sprite size divided by 2. Then we need to calculate its position. We will do CG point. We will take the double of x times sprite size, and we will take the double dot y times sprite size, and set this position. And we need to add these as a child, and we also need to offset them with the same offset as our field. Let me show you what happens if we don't. So now these are all these should be sort of filling up this this space. So you should add the offset, and this requires an extension on CG_point, a static function plus that takes a left-hand side and the right-hand side and returns a new CG_point. Okay, let's see what happens. Okay, we're almost there. The one problem we have is that we draw these circles from the center of the circle, so the midpoint of the circle, so we need to offset them a bit to really let them fit into the play field. So what we'll do is we'll add a CG_point. That is the half of the sprite sizes for X and Y coordinates. That should be enough to move them by the radius off, and now they fit perfectly. Normally these of course would have some fill color. Let's fill them with green for now. And this is more or less a completely green filled play field. Of course, this is not what we're going to be wanting to do in the end, because what we want to do is draw only those gems that are in active play. But let me quickly check how long this is going on. 15 minutes. Let's quickly create a bit of model to store the information about our game state. We'll create a board, and this will be a representation of all the gems that are in play. So we will create a struct called board, and this will have a couple of gems, and these will require a map from a vector to a gem. A gem we haven't defined yet. For that I'll use an enum called gem, and this will have a couple of cases. And we also need a vector. For this I'll create a new file. And this is more or less similar to something we created earlier already, but for now this will be mostly storing an X and a Y coordinate in integer form. And this one should be hashable. That way we can use it as a key into this board. We should also be able to get back a gem. And it's an optional because we might request a coordinate where there's no gem at a specific time. And I think this should be enough to implement a very simple board. So let's go back into our game scene and let's create a board. And instead of doing this, what we can do is take our, just add a couple of gems on the board. And then we create a function that draws the board. So we call it at the end. And this one will go over each gem in board.gems. We need the position. So we need a CG point. This is a bit weird. Oh, that's because board should be a member of the class, not of just this method. So we take the x-coordinate of the gem and multiply it by the sprite size, meaning that sprite size and actually all these constants also need to be part of the class. And we need to add sprite size dot divided by 2. This is the offset of the half of the circle, and we need to add the offset as well, meaning that offset needs to be here as well. So instead of a let, we need to have a variable that we can access outside of the function scope as well. And then we can create the shape node. A circle of radius sprite size divided by 2. The position will be the position, and we will add the gem shape as a child. Yeah, we're not using, let's not go into coloring and so on just yet. So let's run this for now. Okay, so we have the one that's all the way here. I draw it outside of this field because this is where a new gem will fall in, and this one is indeed at the 0, 0 position. So one addition I want to make is I want to have a root node that I will add to our scene. And this is also where I want to add the gems. And the reason is, in this way I can go first into clear out all the existing nodes. When I draw the board. So this cleans out all previously rendered gems and then renders the new ones. So I do think that this is a good start, and I want to leave it here for now. Next time I want to work on two things. First off, I want to have the gems have colors so we can draw them. And second, I want to have them fall, because I think that's one of the defining behaviors of this game. I can imagine that this episode was going a bit fast and not always very clear. starting these things is always the toughest thing. But we now have a play field. We have the basic structure to define our game state. I think it will be a bit more smooth sailing from here on out. So thanks for watching and have a good day.